Hello everyone, this is Professor Robert Solis. Welcome to our next video lesson. We're going to talk about the Pascal triangle. Now the Pascal triangle is basically the addition of the two numbers above it to give the, I shouldn't say the addition, the multiplication of the two numbers above. No, I'm sorry, it is the addition to get the resulting number. So for example, 1 plus 1 is equal to 2, 3 plus 3 is equal to 6, 10 plus 10 is equal to 20. 1 plus 6 is equal to 7. And you can think about imaginary zeros outside over here and also imaginary zeros outside over here. So if you saw a 0 plus a 1, that's where we get the 1. And the 0 plus the 1, that's where we get this 1. So forth and so on. Okay. So the first thing to notice is that based on the number of rows that the person wants to see, we're going to be displaying what's referred to as this Pascal triangle. And we're going to use this particular equation right here, where this is called factorial, so that means a running product. Like 5 factorial would be 5 times 4 times 3 times 2 times 1. So the Pascal number is if you give it a particular row, and so the rows are defined as items that go left to right, right to the left, and an element is like an inclined column. So if I said, what is the Pascal number for row 3, element 5? Okay, so element 5 would be over here. Oh, I said row 3, that doesn't exist. So let's say row 5, element 5. So element 5, row 5, that would be that number right there. This guy over here, as you can see, is row 7, and that would be element 4. So if I know the element and if I know the row, I can plug it into this equation and get that particular Pascal number. And so we're trying to develop a program that allows the user to enter a number. So over here it says enter an integer from 1 to 10. If the user enters an inappropriate integer, then we want to say invalid entry. Again, enter an integer from 1 to 10. This is inappropriate, so it's an invalid entry. Finally, when the user gets it right, in this case they want to see a 3-row Pascal triangle. So you see 1, 2, 3, and this is the Pascal triangle, which is what you see over here. Okay. So that's what we're going to do. In addition to that, we are going to make a function called factorial that calculates the factorial. We send a number to it, it's going to determine what the factorial is. We're going to create another function called Pascal num so that we send to it a parameter. As you can see here, this function contains 2 integer arguments, the row and the element, and then it's going to return an integer, namely the Pascal number. And we're going to plug in this equation which uses the factorial to determine what the various items are over here. Okay. You'll also notice a strategy. How does it that this thing looks like a triangle? Notice after every 3-digit number that you see a space. Notice after every 2-digit number you see 2 spaces. Notice after every single digit you see 3 spaces. And so that's how we're able to get what looks like a triangle. I'm taking the largest number, and I'm going to add 1 space after that. The largest number happens to be a 3-digit in our particular example because we are asking the user to enter an integer from 1 to 10. So as you can see over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For 10 rows, the biggest number is going to be a 3-digit number. But what if I change my program so that I want it to be able to display from 1 to 15 or 1 to 20, say, for example? Well, then it's possible that we can get into a 4-digit number. And if that's the case, if we had a 4-digit number, we would want to add a space. A 3-digit number, 2 spaces. A 2-digit number, 3 spaces. A 1-digit number, 4 spaces. So in other words, my job is going to be to look for the largest number and then display only 1 space after that number, and then it works backwards for every other number. Now, I've solved that problem for you by saying, hey, the user is going to display up to 10 rows for the Pascal triangle. If you see a digit or a number that has 3 digits, then just simply put 1 space after it. 2 spaces for a 2-digit number, 3 spaces for a single-digit number. That's why you see this particular approach. Okay. All right, so let's see here. This is really an exercise in functions and pretty much just, logically following through with this particular procedure. So let me go ahead and switch over to Visual Studio. I'm going to open up 2015. Actually, you know what? I can already tell that the font is really small for this, so let me just change this really quickly here to something like this. That's better. And we're going to create a new project. This is going to be a C++ program, Win32 console application, CS225. And this is going to be the Pascal triangle project. And of course, we're going to have an empty project. I'm going to go to the Solution Explorer, Source Files, right-click, add a new item, C++, of course. And then we're going to start off with our boilerplate code, which is include IOStream. I'm also going to include the string library, and then using namespace, std, int main, and have a system pause, and we're also going to return 0. We are also going to have our various sections such as the declarations section, the get user input section, perform some calculations, and generate an output. Now, the requirements that you saw on the previous page says that you want to generate these two functions right here, factorial and also Pascal. So I'm going to create the Pascal number function. In order for me to do my job, you've got to give me the row and the element, and then I can do my job. Well, one of the things that the Pascal number function needs is the ability to determine the factorial. So we'll say int factorial, and you give me a number, and I'll be able to return to you the factorial. Well, let's take these two functions, and I'll also copy and paste the semicolon. I'm, of course, going to get rid of those, and I'll paste those down here, and I'm going to get rid of the semicolons and replace those with curly braces, like that. And we'll start off with the factorial function. Now, remember that factorial is basically a running product. So let me just put a comment here to remind you. For example, this let's start off with a smaller number, like 4 factorial. This means 4 factorial, or 4 times 3 times 2 times 1, which, let's see here, 4 times 3 is 12, that's 24, so that's going to be 24. It's a running product. So I'll put IE, running product. That's what we're trying to determine. You give me a number, and I'll generate the running product of that number. Well, there's various ways to do it. Here's how I did it. I'm going to create a variable called fact, which is an abbreviation for factorial. And anytime that I see this pattern of 4 times 3 times 2 times 1, that's a series, that's a pattern, so I think, okay, I'm going to put that in within a loop. And so I'll just simply generate a counter for that. If the number that you sent to me is 0, so if it's equal to 0, then I'm just simply going to return factorial. So let me just put this fact down. I'm not sure if you realize this. 0 factorial is defined as 1. 1 factorial is 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. Mathematicians define 0 factorial as 1. So if the number that was sent to me is 0, then I'm just simply going to return factorial, and you'll notice that factorial is already set to 1. You know that 1 times anything is the anything. That's why I set factorial to 1. so that if I do get the 0, I can just simply return that. What do I do if I didn't get the 0? Like I got a 1 or a 2 or a 3 or whatever else. So then within a while statement, now you could use a for statement, you could use whatever repetition structure you want. I'm just using while in this case. While that counter that I created is less than or equal to the number, then I'm going to go ahead and determine what that running product is. So within curly braces, I'll just simply say factorial is going to be whatever the previous factorial is times counter. So let's see how this works. Notice that first counter is 1. Okay. The number is given to me, like let's say, for example, that 4 is given to me. Is 4 equal to 0? No. All right. So while the counter, which is 1, while 1 is less than 4, yep, okay, take that factorial, right, which is 1. 1 times the counter, that's 1. So factorial is now 1. And so now what I've got to do is I've got to increment the counter. So now counter is 2. 2 times 1 is 2. Then the counter is going to go to 3. 3 times 2 is 6. And then I'm going to say 4 times 6 is 12, and so forth and so on. This just simply is a running product. When I'm done with this guy, then I can go ahead and return whatever factorial is. Okay, so this is a very simple little chunk of code, a function, that will return the factorial based on the number that you give to this. Now, the downside of this particular approach is if I have a large factorial, like maybe 15, 16, or 17, then this program is not going to be very efficient. This function is not going to be efficient. There are more efficient ways of determining what the factorial is. So this is written more so for the smaller numbers, like when the user wants 12 rows, or 10 rows rather. So we can get away with that because the largest number that we'll be generating is, you know, a smaller number based on the row and based on the column, or based on the element, I should say. But for bigger factorial numbers, this would not be a good approach. Okay, but I think we can get away with it in this particular program. All right, Pascal number. So the Pascal number is going to use the factorial function, and we're going to use it in this way right here. The Pascal number, first of all, is the row factorial divided by the element factorial times row minus element quantity factorial. So this is simply plug it in just like this. All right, so what is it that I'm going to return? Well, I am going to return, first of all, I need to determine what the factorial of row is. Okay, so I'm going to call factorial, and I'm going to send to you row. And I'm going to divide you by something, and I'm going to put open and close parentheses over here, put my cursor right back in between where those parentheses are. So that's the numerator. What's the denominator? Well, the first thing is element factorial. Okay, so I'm going to call factorial, and I'm going to send to you the element that was given to me by the user. So that takes care of this portion right here. Times, okay, so that is going to be multiplied by, and what do I have to do? Row minus element factorial. Okay, so I'm going to, again, determine the factorial, but of row minus element. So in essence, we're doing the same thing that this equation is doing. I'm going to determine what the row factorial is divided by quantity, this times this, the factorial of the element, the factorial of row minus element, quantity factorial. And that's it. This thing is going to return whatever that Pascal number is. So now it's time to use these functions to help us determine the Pascal number. See, here's the way that the program is going to work. The user is going to enter in a certain row and a certain column. Or I'm sorry, a certain number, I should say. So enter an integer from 1 to 10. All right, so they enter that number. If they want 10 rows, here's what we're going to do. I need to display all of these spaces and then the Pascal number. I need to display for the next row all of these spaces, a little bit less spaces, and then the Pascal number. Since it's a single digit, I know that the rule is after a single digit, we're supposed to have 3 spaces after every single digit. So 1, 2, 3, and then finally the next Pascal number. Go to the next row. You see that I have a little bit less initial spaces, and then we have a single digit 3 spaces, single digit 3 space. Over here, you'll notice that we have a single digit 3, 2 digits, Well, after 2 digits, then we're supposed to have 2 spaces, so we have that. So we have to read how many digits that we have in our particular Pascal number that we're displaying, but we are doing this. We're going to be generating all of the rows from left to right, and then all the elements as they appear for that particular row. We use this equation to determine, this equation over here, to determine what the Pascal number is for each of these different positions. Okay. So what do I see? If I'm going to be starting off over here at element 0, row 0, that's the first number that gets displayed. Now let's go to the next row. Well, it looks like I'm just simply incrementing from 0 to 1. Now the second row, or row number 1 rather, has 2 elements, as you can see over here. Row number 2 has 1, 2, 3 elements. Row number 3 has 1, 2, 3, 4 elements. So you can see that as the row is increasing, the elements are also increasing for that given row by 1. All right, so 1 number, 2 numbers, 3 numbers, 4 numbers, so forth and so on. We plug in what those numbers are into the equation, and we get the row and the element for that particular column or for that particular location. So now let's go back over here, and in the main program, I know that I'm going to have to get the user number. So I'll create a variable called usernum. Definitely, we're going to need to know what row we are on, so I'll go ahead and create a row counter, and I'll also create an element counter. Set that to 0 as well, because as you can see over here, the row starts at 0, the element starts at 0. So that's why I want to start both of these at 0. Now you'll notice that in terms of the number of columns per row, well, if we're going to start off with that first row, now I said columns, I should have said elements per row, but that's okay. I'm just thinking about these diagonal lines right here. Notice how we have 1, and then we have 2 for the next row, and then we have 3 for the next row, so forth and so on. So that's what I mean by this columns per row. How many spaces do I need to draw? So I need to keep track of that. And of course we have a certain number of initial spaces. And as you can see over here, when I display that first number over here, how many initial spaces do I need over here? So we're going to have to consider that. Initial spaces. And then in general, I'm going to have a counter to go through each one of these different items. So we'll have a counter. And then I'm going to generate a string output variable. I'll set it equal to nothing at first. Okay, so I want to make sure that the user enters the number correctly. As you can see over here, the user entered 14 and -5 when I'm telling them specifically to enter an integer from 1 to 10. So let's go ahead and here we'll say while the user number is less than 1, or if the user number is greater than 10. Because if that's the case, then you've entered an invalid number. And I want the user to enter a valid number. So, if this is the case, what I'm going to do is I'm going to say cout, enter an integer from 1 to 10. We put a space right there. I'm going to obtain that and put the user entry into a variable called user number. Now, if this is wrong, so I'll say if that user number is less than or equal to 0, or if that user number is greater than 10, then that's a mistake, and so I will cout invalid entry and go to the beginning of the next line. That's this part over here. See, invalid entry, then go to the beginning of the next line so we can get the correct data. Go back over here. If the user number is less than 1, or if it's greater than 10, that's an invalid entry. So enter a number from 1 to 10. Now let's say that that number is 5. Okay. So is user number is 5 less than 0? No. How about is 5 greater than 10? No. So it wouldn't display a valid entry. it would go back over here. Is 5 less than 1? False. Is 5 greater than 10? False. False or false is false. Finally, I can jump out of the while statement. So this while statement takes care of this business over here, of making sure that we get the correct entry from the user, and if we're not, we're just simply going to display invalid entry every single time. Okay, now let's go ahead and perform some calculations. So the first thing to consider is the number of initial spaces. There we go. What is the number of initial spaces going to be? So I discovered that if you multiply 2 times whatever the user number is minus 1, that's what you're going to need in order to be able to draw the initial spaces before displaying the number. So what you could do is you can just use something like Microsoft Excel, say for example, or some graph paper, say for example, to discover how this would work out. So let me cancel this and cancel that. Go over here and select this. So let's say for example, if I have a Pascal triangle similar to this one over here. So it looks like I have on the bottom row 1, 2, and 1. Okay, so over here, So if I have 1, 2, and 1, and actually, you know what, let me do this. Let me change this so that 25 pixels and 25 pixels to make this look as square as possible. Okay, so I think what I said was that all those single-digit numbers have to have 3 spaces. So 1, 2, 3, and then a number. 1, 2, 3, and then a number. All right, so that matches what I've got over here. And then the next row has 2 numbers. Okay, so it looks like we're going to put that number over here. All right, so put that number over here. And we're going to have another number over here. And then I have that single-digit number right here. I'll put that right here. All right, so let me center everything here. Center everything over here. Looks like a triangle, right? All right, so how did I get those spaces? Well, let's see here. It says over here, whatever the user number is, and in this case, the user number is 3. So 2 times 3 is going to be 6. 6 minus 1 is 5. So over here, it's saying 1, 2, 3, 4, 5. Actually, I bumped it over here. One more. And then it looks like I'm going to have to bump this over the 3, so that's why we see this over here. We see the 1 over here. And then over here, so that 2 is going to be in the middle, of course, like this. So that'll be 1, 2, 3, and then that 1 would be over here. Then 1, 2, 3, that 1 would be over here. Okay. So we need to determine how many numbers how many spaces are we supposed to start off with. That's the whole idea of this equation, that we have some initial spaces. All right, now what I need to do is to display the actual Pascal triangle. So really that's part of the output. We're going to display the Pascal triangle. Okay, well, we're going to have to go through every single row and every single column. So let me just show you what I'm talking about here. For this row, I said column, but I meant element. I'm going to intermix those 2 words. For this row, display that number. For this row, display this number, then this number. For this row, display this number, then this number, then this number, and so forth and so on. So we're displaying each of the numbers for every single row and for every single element. So I can say while the row counter plus 1 is less than or equal to the user number. Now, you'll notice over here that for the row counter, I started this off at 0. And so that's why I'm adding 1 to that. So as long as the row counter plus 1 is less than or equal to the user number, what am I supposed to do? Well, first, I'm supposed to insert the number and spaces. So I created a counter. I'll set that to 0. While the counter is less than the initial spaces, so while that is the case, output is going to be concatenated with a space, and then I increment the counter. So, in other words, I'm going to generate the initial spaces, right? Insert number of spaces, I should have said. No, that's right, number and spaces. But this part right here is for the initial spaces before the number. All right, once I've done that, I'm going to have another while statement. As long as the element counter is less than the columns per row. Now I know that I'm only supposed to display one column for that very first row. Let's see, one column, then 2 columns, and then 3 columns, and so forth and so on. So at first, it's as long as the number of elements for that particular column are less than the columns per row, then I can do the following. I can take the output and I can concatenate it. The output is going to be the old output, and I'm going to need to display the actual Pascal number. Well, how do I do that? Because output, as you know, is a string. So I'm going to use this to_string function, open and close parentheses. I'll put my cursor right back in there. What is it that I want to convert into a string? Because here's what I've done so far. I've displayed these spaces, those initial spaces. Now I need to display that number. So what I'm going to do is I'm going to call a function that I created called Pascal number. There it is. And I'm going to send to it the 2 items that I need to send. So open and close parentheses. What do I need to send? Looks like I need to send the row and also the element. Well, I have that in the form of row counter, column, element counter. So what we've just done here is we've displayed that number, the number 1. We already displayed the spaces. Here's the number. Here's the number of spaces, and here's the actual number. Well, now I need to calculate how many spaces after, because as I told you, every single digit has 3 spaces after it. Every single digit has 3 spaces after it to get ready for the next potential column. So let's go ahead and calculate spaces between the numbers. All right, how am I going to do that? How am I going to determine if the number is a single digit, 2 digit, 3 digit? I'll just simply use an if statement. If the Pascal number for this given row, for this given element, if that is a number that's less than 10, well, if it's less than 10, would you agree it's a single digit number? So in that case, spaces, set that to 3. Else if, let's call that Pascal number function again, and I'm going to send to you the row counter, the element counter. If that number is less than 100, then that's a 2-digit number. So first I check, hey, are you a single-digit number? Then I check, well, if you're not a single digit, are you a 2-digit number? Because if you are, then spaces is going to be set to 2. And then finally, else if, and I call that Pascal number function and send you the row counter. I'm also going to send you the element counter. If you are less than 1,000, so in other words, I'm asking, hey, are you a 3-digit number? Because if you are, then spaces is going to be set to 1. So I use this very simple approach to determine, well, how many digits does a number have? 1, 2, or 3 digits. And that's how I'm able to determine the number of spaces, because as you'll recall, every single digit must have 3 spaces. Every single digit number must have 3 spaces. Every 2-digit, 2 spaces. Every 1-digit number, 3-digit number, 1 space. All right. Well, now that I know how big the number is, and therefore I can draw the appropriate spaces. So over here, let's put a comment over here, draw or insert spaces. So I'll just simply have a little while statement that does that for me. While spaces are greater than 0, I'm going to concatenate to the output string a space. Then, once I've drawn 1 space, let me go ahead and subtract it by 1. So I've drawn 1 space, 2 spaces, 3 spaces, however many spaces I'm supposed to draw. Now, this curly braces right here belongs, let's say if I select it, you'll see how this is selected over here. So this curly bracket belongs to this guy. Oops, sorry, let me undo. Undo. There we go. And then paste. That's what no. I need to do that. I just want to copy this right here. So copy, Control C, and then paste. Yeah, that's all I want to do. I just wanted to indicate that that curly bracket right there belongs to this curly bracket. We are finished with the inner while statement. So in other words, I have drawn the number of elements for that particular row. And in this case, it's only 1 element. For the next row, it's 2 elements. For the following row, it's 3 elements, so forth and so on. So we've just finished drawing that. I'm going to press my Enter button. So I'm outside of the inner while statement, as you can see. And now I've got to get ready for the next row, which has 2 elements. So we'll say element counter plus equals 1. Why did I do that? How many elements for that first row? 1. How many elements for the second row? 2. How many elements for the next row? 3. So that's what I'm doing. I'm incrementing the element counter to get ready for the next row. Okay, so now what I need to do is see who. Let me see here, the while statement. And you know what? I'm sorry, I made a mistake. This is supposed to be after this while statement. So let me put that right here. Yeah, we're still inside of this while statement. Sorry about that. Now this guy over here, this curly bracket, belongs to this curly bracket. So I think what I'll do is I'll take this, copy, and let me just select that curly braces again and then go down over here. So it belongs to this guy down here. This is why I do things like that. Put comments at that last terminating curly braces, because now I can see what it belongs to. And in this case, I really did want to have the element counter incremented after this statement. Now I'm going to place my cursor outside here. And what I need to do is to insert the carriage return. I think that's how you spell it. And line feed. In other words, go to the beginning of the next line. So the way that we do that is we'll say output. We're going to concatenate that with the other string output. I'm going to concatenate that with a quote \n, close quote. This means go to the beginning of the next line. Call it a escape sequence. And there's all kinds of escape sequences, like \b means backspace, \t means tab, backslash n means go to the beginning of the next line. Okay, well now I've got to get ready for the potential next iteration. So let's go ahead and reset the number for the next iteration. So columns per row is going to increment because I'm getting ready to go to the beginning of the next line. The element counter, well, we start that at 0 because when we go to the beginning of the next row, that's going to be element 0, as you can see down here, right? Element 0. So when I go to the next row, I'm at element 0. When I go to the next row, I'm at element 0. So that's why I set the element counter to 0. Now I did go to the beginning of the next row, so that means that I'm going to have to increment the row counter. All right, now I am going to the next row, so you'll notice over here, if I have a number over here, then I have to go 1, 2, 2 spaces, whatever this was, subtract 2 spaces from it, because that's where my next number is going to be. And then if I take this, 1, 2, that's going to be where the next number is. So I'm subtracting by 2 for every single row that I visit. So we'll say initial spaces is going to be initial spaces minus 2 to get ready for the next row. So then we're going to go back over here to the top of the while statement, which is basically going to consider as long as the row counter plus 1 is less than the user number. In other words, as long as we have rows to draw, we're going to draw the next row, and then it's going to draw all the elements within that particular row. Once we're finished with that, then after this particular curly brace is where the while statement is, we're going to see out whatever the variable output is. Because in other words, we are just simply concatenating everything into this output string, and then we're going to send it to the console. All right, let me click Save All. Let's see what happens. So let me go ahead and run the program. Let me enter some invalid numbers first. For example, I'm going to enter 14. Yeah, invalid entry. I'm going to enter -5, invalid entry. How about 5? Okay, so you'll notice that I have 1, 2, 3, 4, 5 rows, and let's verify that the two numbers above added together give you the number below. So 1 plus 3 is 4, that's 6, that's 4, that's going to work out. 1 plus 1 is 2, 1 plus 2 is 3, 1 plus, yep, looks good. Okay, so we have our Pascal triangle. Let me try 10 now. So run the program again, type in the number 10, enter. Okay, you'll notice that for every single digit, I have 3 spaces. For every 2-digit, I have 2 spaces. For every 3-digit number, I have 1 space. And that's how I'm able to get what looks to be like a very well-constructed triangle. It's calling the appropriate Pascal number function, giving it the element, which is this inclined column, giving it the row, which of course the numbers that go left to right. And I start from the top, work my way all the way to the bottom. So let me stop the program so we can at least observe one iteration and go from there. So let me go ahead and run the program. Let's say that I want 5 rows. Okay, so I stop the program. Here we are stopping time. So it says here, row counter is equal to 0 plus 1. So is 1 less than 5? Yes, it is. Okay, so let me go over here, and we'll step over here. We're setting the counter to 0. So first we draw the number of initial spaces. So initial spaces, as you can see over here, was calculated to be 9. So we're going to go through this 9 times. Now I don't want to have to go through that 9 times. So what I'll do is I'll just place my cursor right here, right click, and say run to cursor. So now output, as you can see here, let me go over here. See the 9 spaces right here between the two quotation marks? So we've drawn the initial spaces. Now what we need to do is enter this while statement, and it says while the element counter, in other words, how many elements do you have for this given row? As long as it's less than 1, that's a true statement. So I'm going to go over here. And what am I going to do? I'm going to concatenate to the output, which you see over here. I'm going to concatenate whatever that Pascal number is. Well, when I step through, as you can see here, output is 9 spaces and then that number 1. All right, is that a single-digit number or a 2-digit number or a 3-digit number? Well, that really is a single-digit number, so that's why we set spaces to 3. So now that I know the spaces, let me go ahead and draw all those spaces, and I think what I'll do is I'll just simply run to cursor, because this part is going to draw all the spaces. So now when I take a look at output, see what it looks like? I can just actually let's do this here. That's what I wanted to show. The spaces before, here's the number, here's spaces after. Okay, I'm getting ready now to go to the next element. So I'm going to increment that by 1. As long as element counter, which is 1, is less than columns per row, which is 1. Oh, that's not true. So we're going to jump out of that while statement, go to the beginning of the next line, and then get ready for the next iteration. So that's what all this stuff does. We go back to the while statement. Now we're getting ready to draw the next row. So set the counter over here. Let's draw those initial spaces. So I think I'll just simply run to here, right click, run to cursor. And let's see here, is there a way that I can take a look at output? I think I can take a look at output like this. Ah, there it is. So see all the spaces, here's the 1, and then there's the cursor right there, waiting to draw a number at this point. So I'm going to close this. All right, element counter is 0, columns per row is 2. Yep, we're less than, so let's go ahead and enter into that while statement. And so what are we going to do? We're going to we're going to concatenate whatever the Pascal number is for this row, for this element, to the output. So here we go. Let's take a look at output. Oops. There it is. So here's the number. Here's spaces. Here's the number. Now I need to draw spaces so I could draw the next number after that. Well, is this a single digit, 2-digit, 3-digit? So that's what this section does. We draw the spaces, and then we get ready for the next iteration and go from there. So now let's see what our output looks like. Here we go. So we've drawn that first element or that first column. Shall we draw a second column? Yes. So we go over here, and now if I take a look at output, here's that second number. And we're going to draw 3 spaces, then go to the next row and continue to draw all the numbers and all the spaces. So take off this, simply hit continue, and you see what that looks like. Okay. So that is how you solve a problem like this. We're going to use functions. We're going to use them to draw the or to determine the factorial, to determine the Pascal number. We are simply going from every single row through every single element, or we can think of them as a column, to generate the various Pascal numbers step by step. And that's it. So this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.